Alright, let's take another look at some examples that we want to solve, solving systems of equations. And the way these guys are set up is going to be best for us to use the elimination method. The reason we say that is because they're both in standard form. Variables are on the left side and constants are on the right. Now looking at this guy right here, do you get any of the x's or the y's to cancel immediately? The answer is no. So that means we need to multiply one or both of these guys by something so we get a variable to cancel. And what's going to work for us here is a -2 on this top equation. If I use a -2 here, -2 times 5x gives me a -10x, so that guy's going to cancel. So let's see what happens whenever I do that. My second equation doesn't change. It's still 10x plus 4y equals -3. And my top equation now becomes -10x. Keep distributing. That's a -4y, and that equals -14. So just like we wanted to have happen, these x terms cancel. Great. How much y do we have? Uh-oh. These guys cancel as well. That means on the left side we have 0, and what's on the right side? Well, that's -17. Now we've seen situations like this before, where we seem to do everything right, but then all the variable terms cancel. Now we look at this and we determine whether or not this is true or false. Well, 0 obviously does not equal -17, so this is a false statement. And what that meant to us before, when all of the variables cancel and it was false, this means there is no solution. Now I've got a question for you. What does it mean to be no solution here? Keeping in mind that we're trying to find out the point that these guys have in common, and another way of saying that is finding out where these two lines intersect. So how can you have two lines with no solution? Well, that means that these two lines don't intersect, which means that we have parallel lines. Two lines that don't intersect would be parallel. They would have no solution. Okay, well let's check out what we have over here in red then. So this guy we said is no solution. So when it says solve, you respond with what type of solution? No solution. Or if there's an ordered pair, you give the coordinates. Now the guy that's here in red, what can we do here? Well, let's see. These guys don't cancel. Those guys don't cancel. It's going to be tough for me to multiply 4 times something to get the 6. Well, one of the little tricks we have is to take these coefficients and just swap them around. So if I put the 6 up here and the 4 down here, look what I have. That would give you a positive 24x, a negative 24x, so we know these guys would cancel. But something else to keep in mind. See how these guys have a common factor of 2? If I use a 3 and a 2, if I just reduce those guys by a factor of 2, let's see what I get. That gives me 3 times 4x is 12x, and 2 times -6x is -12x. So it's still going to cancel, but we get to do it with smaller numbers. So let's see what this one looks like. When I multiply times the 3, I get positive 12x, get minus 18y, and 3 times 14 is 42. The second equation, I multiply 2 times everybody, I get a negative 12x, a positive 18y, and this equals negative 42. So let's see how this compares to the other equation, or the other system. These x terms cancel, they become 0. The 18y terms cancel, so we get 0 equals, let's see, 42 minus 42. Well, that's 0 as well. Now over here, we said this was false because 0 doesn't equal negative 17. But does 0 equal 0? Yes, so that's a true statement. Well, what does that mean in terms of our solutions? I think it makes sense that a false statement means no solution, but a true statement means something different. If you have where all of the variables legitimately cancel, and you have a true statement, that means that you have an infinite number of solutions. You have an infinite number of solutions. Now, how could that be? How could you have two lines having an infinite number of solutions? Well, that means if each solution is a point where they cross, these lines cross each other an infinite number of times, but the only way that you can do that is if these equations are really the same line. And what you should do here is take each of these original equations and solve them for y. If these guys really are the same line, then when you solve these guys for y, you're going to have the exact same equation. Over here we said these guys were parallel. That means if you solve each of these equations for y, they won't be exactly the same. They will have the same slope, but they'll have different y-intercepts.